Hey, working on daily quiz 3. Remember, one of the goals, major goal of this class is fluency. We also using word of the day as an example of distributive learning. So we haven't kept up with it in the last few days. So let's see if you can remember what the letters stand for. You can pause, think about it. E, esoteric. After you hear the word, maybe it brings back a memory. Okay, only a small group understands what we're talking about here. V, vacuous, not the sharpest tack in the box. Okay, kind of lacking content, not the brightest. E, enervate. Kryptonite, it's an innovative process that disabled Superman. Weaken, so think of weaken, enervate. R, I forget which one we did first, but there's 2 R words. Let's go with restive. When you see the word rest, you think about being, calm and, kind of laid back, and restive is got IVE. You can think of those letters as inverse. So restive is impatient. Yoke, tied together, ribbled, coarse, crude behavior, humor, something like that. Effulgent, splendid, beautiful. The palace was an example of effulgent mosaic architecture. I don't know. So splendid. And I'll put those words with their definitions and usages on your worksheets. And I encourage you to look at them. They're all SAT words. It only takes however long. Go back and see when this started, just to mention them. And it's that constant repetition mentioning that will give you a working knowledge of those. You'll see it in text, in newspapers, magazine articles. Does anybody read a magazine? You'll see it online, I'm sure, reading some articles posted. All right, so where are we at? Well, we're at 2 weeks in, and I hope people already have this down, but it's so important that I am going to make it a quiz. So you're going to get 4 questions. And I'm starting with, unfortunately, orange writing, but I hope that it's still, you still can see it and follow it. Let's see. So 2 coordinates, 2, 4, and 521. I kept changing them because I don't like seeing the same numbers appear anywhere. And we're looking at H. I guess I got to call that some other function. Let's call it n of x. All right. So F is a 1-dimensional conversion. G is a 2-dimensional conversion. H is a 1/2 dimensional conversion. The language I just used there was a little awkward. An absolute value is an absolute value conversion. All right, so what's the conversion process? The conversion process is based on, let's come over here, and then you can see it maybe with the examples I have. The conversion process is really making that first dimension 0, eliminating it, and you still have multiplication over here, and you still have a change, a 1-dimensional change here. So some kind of multiplication times 0 gets us C. And then the second usage of an x value, we're creating a division of 1, which gets us m plus C. Okay, so we've got the numbers 4 and 21, which means that we're going to get the number 4 the first time and the number 21 the second time. And your challenge is to see it happen. And the same process happens in the second degree equations. We're going to get rid of second degree change, and we're going to divide second degree change. I'll put that there, second degree change. And what we're really creating is cancellation of 1, which gets us m plus c. Happens in the 1/2. Now, why did I pick 1/2? Because of fluency. I don't know how many of you know what that means at this stage. You've heard it for 2 weeks. You've seen this exponent for 2 weeks. And now that I'm stressing it, maybe you're taking a little more time to think about it. And I hope that you recognize that 9 to the 1/2 is the same thing as the square root of 9. And that's what this course is about. That's your responsibility as a student. When we work on something like that in class, I'm testing you on it. And your grade will be determined by how much you convince me that you know what you're looking at. And I'm giving you plenty of time. Right? I'm hoping that these 4 calculations, some of the students in class right now can snap their finger and do all 4 in 10 seconds. 10 seconds. I could do these all of these in 10 seconds. All right, maybe I should demonstrate that. Well, let's see, it takes maybe 6 seconds to do the first one. I think I could, maybe 12 seconds. I'm gonna have to time it sometime. All right, but if you understand the first one, you own the others. If you understand the conversion process, that's what this is about. So let's have at it. Let's take a look at one situation. And then we'll do one where I change the numbers and let you have at it. All right, so here's a first dimensional conversion. And remember, we're trying to make a 2 turn into a 4 and a 5 turn into a 21. Well, what is 2 minus 2 to the first power? Sure looks like it's 0 to the first power, which is 0. And 0 times any multiplier is 0. I guess I got a 4. Oh, yep, that's what I wanted. And then the second x goes in, and I put a 5 in here. Well, what's 5 minus 2 to the first over 5 minus 2 to the first? Well, that seems to cancel. And I get the change, the multiplicative change right there. That's really what I'm multiplying this by, 17. And it's really times the number 1 now, because that goes into that 1 time. And 17 plus 4 is 21. And that's a one-dimensional conversion. Do we need to write all of those values like that? No. We could have simply looked at this and said, oh, x minus 2, we didn't have to write the 1. Then we could put the 5 in and get a change of 3 and 17. And I think most of you can do that now. But folks are having a little trouble with the next one, which is a 2 getting us a 4 and a 5 getting us a 21. I guess I did show that over here already, and you can see it. I hope you can read it. It's in orange. All right, so what do? Well, it's a 2-dimensional conversion. So we put the first number in 2. 2 minus 2 squared, that's 0. 0 times whatever this multiplication is 0. Looks like I get 4. Yep, that's what I wanted. And why is it the vertex? Because 0 squared is the smallest outcome that you can get from the squaring process. You put any other number in. You put any other number, and that's going to be a minimum, and this is a minimum location. So what do we have? One more operation. So we put a 5 in. We want it to come out as 21. Well, there's 5 minus 2 squared. I'm canceling 5 minus 2 squared using the second x. And there's your 17 plus 4, 21. And you got to think about this long enough until you understand it. And if you give it thought and you still don't understand it, then you look at it again the next day. And that's how the brain works. Brain is working on it. May not be immediately seen. And you better get used to doing that because the math gets harder at every level. Guys, you got to learn to be uncomfortable. You got to learn to be comfortable being uncomfortable. So I hope you're watching this. I found out on the last daily quiz that you weren't. Half of the class did not look at the video I posted. Oh, don't get me on a roll here. All right, so what was this one? Well, 5 minus 2 squared is 9. Okay, 17 ninths, and I'm dropping in different numbers here. So I've got 17 ninths x minus 2 squared plus 4. And in order to understand concept, you got to get the mechanics of that down first. And it's very similar up here, except this is that to the 1, that's to the 1, and this one is that to the 2, that to the 2. And that's why I could do this in 12 seconds, because once I write that one, all I got to do is put a 2 and a 2, and I got this one. And really the same process here. All right, now, instead of writing 1/2, I'm erasing it. And you're gonna use that symbol. Same thing here. But it follows the same process. So when you put a 2 in, you get the 0 times something giving you the 4. And when you put the 5 in, cancellation, 17 plus 4. Principles of conversion. And this is really, it doesn't matter what X we use the second time. That's the conversion. We would, if you put a 2 in, you really can't divide by 0, but for everything else, it works. All right. And square roots. Remember what square roots are geometrically. Square roots are these lengths, and I can make that length smaller. I can make it smaller. But the smallest I can make it is 0, which means this has a minimum. So that's what, I guess it's over there. So 2 gets you 4, and 5 gets you 21. And I was going to bring up my inverse, but I'll make one up right now. Make one up. No, I'll show it to you in class later. The little switch the X's and the Y's, and you can see the shape materialize. And absolute value is the same concept, measures distance from 0. And so we want the number 2 to act like a 0. That's why we're making that statement. And then when we have this operation, we have to cancel the same way we've done in each of those. I guess we're ready to get one practice in. And then you're going to get these 4 problems tomorrow with different numbers. All right, so let's start with the linear. And I think it's a good idea because some of you are having trouble identifying X's and Y's. There's your first X, there's your second X. Obviously, that's your first Y and second Y. But might be more helpful for you to put it in a table like right now if you're struggling. If you are struggling, you got to do that so that your brain sees what's going on. So -3 gets us 8. So X plus 3 makes the 0. Doesn't matter what the multiplier is. When I put -3 in, that's gone. And I've got the number 8. Okay, and now I got to get from 8 to 12. So that means from 8 to 20, sorry, from 8 to 20 is 12 units of change. So that part's no problem. And what do I get when I put a 4 into the first power? 4 plus 3 to the first is 7. When I put that second X. That's the linear tying the X's and the Y's together. And we're obviously doing a lot more with linear functions than just that. But got to be able to write the equational lines from 2 points without any trouble. You're going to be using that a lot in your career. All right, so let's try the quadratic now. Let's get some different numbers. Let's get -29, and I'll put this underneath so you can kind of see the tabular form. Let's do 3 gets you 20. All right, so quadratic is a 2-dimensional picture. So I got X plus 2 squared plus 9. So when I put -2 in, again, we talked about 0 squared getting you a minimum value output. And now I've got to get from 9 to 20. It's 11 units of change. The only way I'm going to get these numbers is to cancel these things out. I can cancel them out if I, put a 3 in here. And it's 2-dimensional change. Well, I think I've created 25 units of area. Okay, so this is the second, gets plugged in there, and it's 2-dimensional change. I'm done. Now that's not rocket science, and it's been 2 weeks that you've been trying that. If you're not getting that, come in for math help or play it again until you do get it. Because we can't talk about this conceptually and where we're going if we can't do that mechanically. There's not too much we can't do mechanically in math. Numbers kind of speak out to you. All right, so I would hope that you would say 25. Now, if I wanted the linear, it's 11 over 5x plus 2 to the 1 plus 9. That's all that is. And I hope you can see that that's just boom. So if you can write the equation on a line, if you just remember that for right now, you're at least getting the one is the vertex. I hope I said vertex here. That's where the pattern emanates from, symmetry. All right, so obviously if we were doing this, we get 11 over 5 to the 1/2. I wrote it as 5 to the 1/2. Again, I hope you recognize something to the 1/2 means the square root of 5. And so there you got x plus 2. And so you put your x1 in and your x2 in. And I hope you can see that if you put those two numbers in, you should put them in. You should put -2 in, plus 2, 0 times anything gets us 9. You should put 3 in. 3 plus 2 is the square root of 5. The square root of 5 is canceled. You get x 11 plus 9, which is what you need to get to the second. All right. And then if we did the absolute value, all we're doing is this. And we have the absolute value of 5, which obviously is 5. But if this number was less than -2, and we had a negative here, right, the absolute value is always going to get us very similar to the linear. Except our change is different. How's our change different? X plus 2 is a line that goes through the x-axis at -2, which means the y values on the right are positive, the y values on the left are negative. And if I slap an absolute value on this, those negatives become positive. So we get a sign change at -2, and we'll be exploring that in depth going forward. So my encouragement here is to put a little more time, and there was no excuse. I know I heard excuses over the weekend. Oh, I had so much work, I had papers. Baloney. And you had a teacher who used to say, balderdash. You can't tell me that between 7 o'clock Friday night and 7 o'clock Monday morning, you couldn't find a half an hour to look at a video. All right, I got a feeling you looked at a lot of videos, so figure out how much time you spent on the other videos, knock off 30 minutes, come back and think about this for 30 minutes. You're going to do a heck of a lot better in this class. Okay, there's my parental lecture. That's my parental lecture time. And remember, people who go to the board do better than people that sit at their desk. I've never forced anybody to the board, but if I can see your work, I can make commentary and help you make changes. If I can't see it, you're on your own. There you go. How's that for a balderdash? The Irish is coming out of me. All right, see you in class today, and let's see if we can make some gains.